Hello guys, welcome back. So here we have a question from GATE 2018. Consider the network shown below with R1 equal to 1 ohm, R2 equal to 2 ohm and R3 equal to 3 ohm. The network is connected to a constant voltage source of 11 volts. So this is the network. The magnitude of current in ampere accurate to 2 decimal places through the sources dash. So this is the circuit. So to see it may look complicated, but actually there is a symmetry. If you see, the circuit is symmetric along this line. So what does it mean? Whatever current flowing in this branches will be same in the other branch also. Similarly on this side. So whatever is flowing inside this should also flow inside this. Whatever is flowing here should flow here. Here should flow here, and same throughout. And whatever voltage here should also appear here. Whatever here should appear here. And that's it. So now we can simplify based on this observations. So whatever voltage is here, if it is also same here, let me call it VA, there will be no current through this R2, correct? So we can remove this R2 without affecting the circuit. Similarly, whatever voltage here is going to be equal to whatever the voltage is here. So R2 also there is going to be no current. So we can remove this as well. So now since these voltages are equal, effectively we can also place a short between them without affecting the circuit. Right? And now if you see, these R1s are appearing in parallel with each other. And here if you see R1, R3s and another R1 is appearing parallel, and down again two R1s are appearing in parallel. So to see this as an example, let us say we have two resistors R1, R1, and this is some node A, this is B and C. Let's say B and C are each 5 volt. So effectively looking from here, what will be the net voltage and resistance? So here it is gonna be R1 by 2 and this is gonna be 5 volt, right? They have an equivalence looking in from A. So this is nothing but this voltage is same that we are writing as it is, and the resistance was nothing but it become the parallel combination of R1, right? So that is because we were able to short these both and connect them to 5 volt, right? Effectively it is the same. So here also we have done the same only. So these circuit techniques are handy to actually easily solve and simplify these questions. Again, when you do that, you should be very careful and you should ensure that there is no current through these. So here again, since these voltages are equal, there will not be any current through these. Okay, so here what do we have? We have R1 by 2, and in the middle what we have R3 by 2 plus R1 by 2. Sorry, it is parallel. So R1 by 2 parallel with R3 by 2, and down we again have R1 by 2, and this is connected to 11 volts. So if we revisit the value of R1, R2, R3, it is 1, 2 and 3 respectively. So this is 0.5 ohm, this is 0.5 in parallel with 1.5, and this is again 0.5. So what is 0.5 parallel with 1.5? 0.5 into 1.5 by 0.5 plus 1.5, which is 0.5 into 1.5 by 2. So it is 1.5 into 0.25. So this is equal to 0.375. So what is the total resistance? 0.5, 0.375, 0.5. So total resistance is 1.375. So what will be the loop current? We need to find loop current, right? So I is equal to 11 volts by 1.375. So if we use the calculator, this comes to be 8 volts. So the answer is 8 volts here. And we need to round it off to 2 decimal places. So we can write it as 8.00.